Hello students, today we are going to see something important competitive based questions. In that they will give some questions which is related to the topic only. In that four options they will provide, in that which is correct, which is wrong, why they are wrong. Such kind of way we can analyze it. Let us go for that. Here identify A, B, C in the following reaction. So this is the reaction. This methyl halide, methyl chloride reacts with potassium cyanide. It gives compound A, and undergoes hydrolysis hydronium ion H3O plus, it gives B, and then alcohol, ethyl alcohol, it gives C. Now we have to identify. Let us go for the first one, methyl chloride CH3Cl combined with KCl. What happened when it reacts? Potassium cyanide, it is a ionic in nature, we have gone through, and in that ionize very fast. Potassium cyanide, it is ionizes very fast, so carbon acts as a nucleophile that will replace, that will attack that, what it is, carbocation formation. Now you will get the KCl, and then C, it will go and attach with that cyanide compound. See, it is dominating. So carbon acts as a nucleophile in that point, which is going to attach with that methyl group. So you will get CH3CN. Yes, the first option, it is A, CH3CN. In that CH3CN, these are all these three things are, that means this is wrong. The first option, it is wrong. Now second option, yes, this is CN, this is CN, this CN, yes, it is. Let us go for this. Now, second one, this CH3CN reacts with hydrolysis. That means hydronium ion CH3, sorry, H3O plus. Here what it is? Hydrolysis H3O plus. Just I will put it hydrolysis only. Hydrolysis. Hydrolysis. H3O plus. So H3O plus means it is two water molecules are available, H2O plus H2O. So you will get H3O plus. So that means here cyanide compound usually when it undergoes, it gives amide compound. Yes, CH3CO NH2. If it is only water means this is correct. So that means here the second option, totally this is wrong because this is also wrong. So naturally that is also wrong. Here COOH, here CONH2, yes, but hydronium ion they have given. Hydronium ion, that means another one more time it reacts with water. So CH3 CONH2 reacts with again one more water. So that means you are getting what it is, CH3COOH, acetic acid. So this is actually two reaction. That's what purposely they have given hydronium ion. This is the key point they have given. So you should think it in that way. Okay, hydronium ion. So only water hydrolysis means naturally amide only. This might have been as a possible. Right. But when we are coming here, again hydronium ion they have given means again it reacts with water. So this is the correct answers, acetic acid. So that means option which one will be considered? This one and this one. Maybe. Now this is correct and this one or this one. Let us go and check it, but this one won't be because this has to go one more time. So this is cancelled and this also will be cancelled. Third option also cancelled. That's what I mentioned. Why it is wrong? What are the reason? So this is wrong because isocyanide will not come because it is potassium cyanide is ionic in nature. Ionizes very fast. Whereas if it reacts with silver cyanide only, you will get isocyanide. So this is potassium cyanide. So totally it is wrong. The second one, it reacts with water. That means hydronium ion. Hydronium ion if it reacts means what it is, acetic acid, acid group, carbonyl group only. In the two are there. So acetic acid only it is possible. So in that two it is correct. But third one, let us see. Hope you are clear with it. Okay, let us go for another one more reaction. Is it clear? Okay, third one, acetic acid, you got it. B option. So in that CH3COOH plus C2H5OH reacts with water. So usually this hydrogen will be replacing by methyl or ethyl. So that means what you will get it CH3 COOC2H5. So that means what you will get it here ester formation. So that means this is anhydride CH3CO twice O anhydride formation. But here it is ester formation. Yes, I got the answer. So option 2 it is the correct answer. Other than that, this is fourth option also wrong. Why? This correct one and this is also correct, but third answer it is wrong. Why it is wrong? What it is? Acid and alcohol combined, you will get ester formation 100%. That is carbonyl and its compounds. We will go for it. Okay. Hope you're clear why it is wrong, why this is correct. Hope you're clear. So the third point C, this is option C. It is ester formation. Hope you're clear. Let us go for the third. Next question. The next question it is electrolysis of aqueous sodium acetate, it gives B at anode. B when heated with chlorine at 400 degrees Celsius it gives C. When C reacts with excess of alcoholic ammonia it gives D water, which is correct option. In that we have to identify which is correct, which are wrong, why they are wrong. Come on, let us go and analyze it. That first one, electrolysis of sodium acetate. Electrolysis of sodium acetate only we will come to know a very famous reaction. It is called reaction called the electrolytic process method. Okay, now in this CH3 COONA. So what is the product you will get it? You know, alkane. So two carbon it is there. So naturally it is ethane. Okay, CH3COONA undergoes electrolysis. You will get, as I said, C2H6 plus CO2. Carbon dioxide will be coming out. Now this is compound B. Major thing only we have to identify. Now this is C2H6 combined with heated with chlorine at 400 degrees Celsius. So what you will get it? This is free radical mechanism. So C2H5Cl plus HCl. Okay, now this is the major product only we should consider. This is C. In that C reacts with the excess of C. What it is? C2H5Cl combined with the excess of ammonia. Excess. So excess means you will get methyl chloride reacts with ammonia. So you will get methylamine first. Excess they mention. So first and foremost, if they did not mention excess means you will get this option. But they have given this option, so this is wrong. Right now, final product only we are coming. So this is wrong. Now in that, so 3 times, 4 times it has to. So the first one to NH2 will be coming, then NH double time, C2H5 twice, NH, then C2H5 thrice, and like that, then 4 times, that means C2H5 4 times, N plus Cl. That is a salt formation. This is a long line. I think you have gone through this process. So what is the final answer here? C2H5 4 times N plus Cl minus. Okay, so the answer will be N plus Cl minus. So that means answer will be B. But the option A it is wrong. Of course, D we mentioned it is wrong. And C also it is mentioned wrong. Why? Because this is the... Now let us go for the complete reaction. C2H5Cl Cl combined with ammonia in excess. So what you will get it, the first one C2H5NH2 and C2H5NH2 again reacts with ethyl chloride because the excess they mentioned, no? So this is again you are adding into that main compound. So C2H5Cl. So you will get two times, no? C2H5 twice NH. Then HCl will be removed. One hydrogen will be replaced in the chlorine. Okay, now in next one, what it is? Again, this twice, right? So yeah, it's twice. C2H5 twice NH combine again C2H5 Cl. You have to completely remove this H. Okay, so you will get the primary, secondary, tertiary, like you have to remove. So that means here CH, C2H5 thrice N. Right? So hydrogen will be out. Only one hydrogen that is also removed. Now again excess C2H5 thrice N plus C2H5Cl. It gives again C2H5 4 times N plus Cl minus. Okay, now this is wrong. Why I said it's wrong? Because first step only it is getting. Now in that second step, this is also wrong. Why? Third step, because excess you are getting. When it comes to that excess, you are getting this compound only. So this is correct. This one. Why they are wrong on this? I just mentioned because final product only we want. Right. So final product only they asked it reacts with excess of alcoholic and NH3. So you are getting. Hope you are clear with it. Okay. Let us go for the next question. Hope you are clear. Yes, let us go for another one more question. Order of nucleophilicity in polar aprotic solvents. Polar solvents, when we are talking about polar solvents only, polar protic solvents, polar aprotic solvents, two kinds are there. In that polar protic solvents which gives H plus ion, which are the examples? H2O, alcohol, acid. So these are all comes under polar protic which gives H plus ion, whereas polar aprotic solvents which does not give H plus ion. So example, what are they? It is acetone, sulfoxide dimethyl sulfoxide, dimethyl acetamide, dimethyl formamide, amide group and acetone keto group will be coming under this polar aprotic solvents. Now why I'm giving that, you should know what it is polar and apolar, then we can go and solve that problem. Yes. Okay, now the next point what they are asking, in that order of what it is, one nucleophilicity in polar aprotic solvents, they mentioned here I minus, Br minus, Cl minus, F minus and all these things they mentioned, that four options. So generally nucleophilicity order, as you are talking about this in periodic table. So when it is coming down the group, nucleophile will be increasing in order. So now in this they mention what it is, halogen part only, no? So halogen, fluorine, chlorine, bromine and iodine. So when it is coming down the group, so nucleophilicity order of the nucleophile will be increasing. So that means which will, now let us analyze that polar protic and polar aprotic in that halogen part in periodic table. Why? We can identify which is correct and which is wrong. Okay. Now, as it is coming down the group in the periodic table, nucleophile, order of nucleophile will be increasing. And that means order of nucleophile will be increasing means, shall we put it like this? So that means I minus is greater than Br minus is greater than Cl minus is greater than. So that means polar protic, I'm talking about polar protic solvents, as it is coming down the group, the nucleophile order will be increasing. So this is I minus, Br minus, Cl minus, F minus. Yes, this is for polar protic. But in the question they asked polar aprotic, just to the opposite. So as it is coming down the group, polar aprotic solvents will be decreasing. So that means here what will be? F, Cl, Br, I. By the time you yourself giving that answer, what is the answer you will get it? Just this. So F is greater than Cl is greater than Br is greater than I. Now let us go and identify which is the correct. F is greater than. F is greater than Cl is greater than Br. It is greater than yes. So the second option it is correct. This option will come for polar protic solvent. Polar protic solvent, suppose they are asking question, you can identify that is the correct answer. Why? As it is coming down the group, that nucleophilicity order of nucleophile will be increasing. So this might be correct for this polar protic solvents. When it is coming for polar aprotic solvents, F is greater than Cl is greater than Br is greater than I. Why? Because in the periodic table, as it is coming down the group, that is decreasing in order, nucleophile will be decreasing in order. Hope you're clear with this, why this answer is correct and why these correct, they didn't jumbled like they have given. So we no need to consider only IBR. Okay, so in these two, this is wrong and this is under jumbled. Just they have given that jumbled. In these two you can identify. So this is the correct option. Hope you're clear with that. Polar protic, polar aprotic, where it is decreasing, where it is increasing. The next question, 1-methyl cyclohexene reacts with hydrogen halide. What is the product? As you look at only, this is unsymmetrical cyclo compound, right? Unsymmetrical alkene, and it reacts with hydrogen halide. 100% Markovnikov's rule only. Okay, so this H plus and I minus, Br minus, Cl minus, here I minus they have given. Now H plus ion where it will go and attach, I minus ion where it will come and attach. Okay, H plus ion it will go and attach where there is a more number of hydrogen, I minus will attach where there is a lesser number of hydrogen. Of course, this point double bond here, no, so automatically the bond breaks. So here you will get the answer over here, the bond breaks. So the bond breaks means here what happened? Here one hydrogen will be joining over, no? So that means you will get that CH2 and here CH3 as it is. In this point, lesser hydrogen, no, in that I will be joining. So you will get this kind of compound. Do you get such kind of compound A? No, it is wrong. In this para and here, this one B. Also it's wrong. Why? Because they mentioned like para and this is like meta. This is not at all correct when it comes to that Markovnikov's rule, and that actually the bond breaks, right? The bond it is not breaking. Why? Because H plus ion which will go and attach to that where there is more number of hydrogen, I minus will go and attach where there is a lesser number of hydrogen. There is no point of here to tell the answer. Whereas here, yes, you got the answer, the same here. So the bond breaks, you are getting cyclo. So 1-methyl, 1-iodo, cyclohexane. 1-methyl, 1-methyl, 1-iodo, iodo, cyclohexane. ANE. ENE breaks ANE. Hope so. Which is the correct option? This is it. Why these are all wrong? Because they did not provide such kind of answer. So as we are coming to that, we will come to know this option. It is correct. Hope you are clear with that. The next question. It's very simple. Which one of the following compound will be more reactive for SN1 reaction? Iodo compound, chloro compound, bromo compound, chloro compound, which the position is changing. As you are looking at only iodo compound is the correct answer, your mind will say. Why? You know that is the best leaving group. Why? Atomic size is bigger, charge density decreases, it will be more stable, more reactive. And one more thing, these options and all wrong. Of course, this will not be coming, and this also will not be coming. Not only this, charge density decreases, so it is more stable, and atomic size is bigger, and best leaving group. And one more point here, resonance, as it is moving out. So here carbocation formation as it is moving. So this also is another one more point to be noted. So first one, it is most, what it is. I know you got the answer. This is the correct option. The first one, best leaving group. Iodine as a best leaving group. Second one, atomic size is bigger. Charge density, it is decreases. And resonance point also, it is more stable. And that is what? More reactive in SN1 reaction. Hope you understand. Thanks for watching.